everyone, welcome back. Today we're going to build a distributed communication network for DNS over HTTPS that runs entirely on systems we control. If you're just here for the goods and you don't want to hear me talk about why DNS over HTTPS is good and why the controversy in the media doesn't matter, then you can just skip to this timestamp and get busy with the deployment. Still here? Awesome. I figure that if you're watching this video, you're interested in DOH, and in your journey, you're going to run into people on both sides of the discussion. I want to spend a few minutes talking about the current state of DOH in the community and give you some alternate ways to think about it that you won't get from the media. This week saw an uptick in chatter about DOH, largely because Mozilla and Google have both started rolling out support for it by default in Firefox and Chrome. Firefox will point to the Cloudflare resolver, and Chrome will of course point to the Google resolver. That move has been hit with some pushback by governments, with the United States government asking Google to promise that they aren't going to use this default configuration for any sort of competitive advantage. Google promised that they wouldn't. Similarly, Cloudflare promised that they wouldn't abuse their position, even though they already perform man-in-the-middle decryption over a massive amount of internet traffic. Now, with DNS traffic overlapping with their content acceleration platform, they'll be sitting on a trove of data about internet users all over the world. I figure there are honest people and there are dishonest people. If you ask an honest person if they're going to deceive you, they'll tell you no. If you ask a dishonest person, well, they'll tell you the same thing. You need to put DNS over HTTPS in the hands of someone that you can always trust. Yourself. The UK government asked Mozilla not to activate DNS over HTTPS in Firefox for UK users, citing concerns over terrorism, child exploitation, and generic security, but really what they said was, please don't do it because then we can't snoop it. Newsflash, people, that's the point. The articles that I read, and that I'll link to in the description, raise other concerns about DNS over HTTPS in the browser. One was that it would allow children to circumvent network-level restrictions installed by parents, guardians, schools, or other authorities. Mozilla responded by saying, for users who accept DOH as the default, network service providers and network admins will be allowed to signal that certain capabilities like content filtering would be adversely affected by DOH. When Firefox receives such signals, it will disable DOH for the rest of the network session unless the user has manually set the DOH always preference. What this means is that unless you've expressly set an always-on flag for DOH in Firefox, it can be silently disabled by network providers or software that indicates it shouldn't be on. That sounds like a good idea in some cases, but it also sounds like it's something that the ISPs can abuse. The same article quotes Selena Deckelman from Mozilla, who says that Mozilla intends to work with organizations that offer network-based parental controls to add a canary domain to their block lists. If Firefox determines that our canary domain is blocked, this will indicate that opt-in parental controls are in effect on the network, and Firefox will disable DOH automatically. What's to stop an ISP from blocking that domain as a means to disable DOH for their customers? This is a war over customer browsing data because it's extremely valuable for advertising and control. Right now, DNS is decentralized and unencrypted, so while you have one type of freedom, it comes at the expense of having your privacy stripped away. DOH solves the privacy issue, but the default implementation in the browser does so by centralizing the control in a handful of companies, some of whom have no regard for your privacy. Paul Vixie, the creator of the original DNS server, argued that DOH is just a campaign by US tech companies to control the DNS resolution path. He said back in March that network operators would be blocking DOH endpoints or forcing them through SOCs or HTTPS proxies to run man-in-the-middle decryption and either intercept or block the requests. He believes that this will be necessary to stop malware from directly querying DOH servers or to mitigate risks of bypassing network security rules. Why do we have to participate in this? We don't have to take a side. We don't have to agree or disagree. We just have to do what we need to do to live our lives in the best way that we can. So for me, that means that I'm going to run DNS over HTTPS against my own infrastructure, and I'm going to share this with you so that you can decide if you want to do it too. In last week's video, I showed you how to run a DOH proxy and a stub on your local computer that will send 100% of the DNS traffic from your computer over HTTPS instead of just requests coming from one web browser. Now, this works, but if you have an external system running Kubernetes, you can provide the other side of that connection yourself. To be fair, you can do this without Kubernetes, but it requires a lot more effort to set it up and a lot more effort to keep it running. That violates Adrian's first rule of system administration, which is create the greatest result with the least amount of effort. It's important to remember our objectives, and yours may be different than mine. I'm not looking to secure 100% of my traffic or hide my behavior from any state actor. If I wanted to secure all of my traffic, I'd run everything over a VPN, although that introduces other trust factors that we're not going to go into today. I've identified that my ISP here in Chile is malicious and blocks DNS to the internet. My sole objective is to get my DNS traffic past their blockade and out to the free, shark-infested waters of the open internet. I have systems out in OpenCloud, DigitalOcean, and Amazon, and I trust each of them more than I trust Intel. I also run a bunch of systems in my house, so I need to be able to reach my internal hosts by hostname. I can do this on macOS by setting an exclusion for my home domains, but then I have to maintain that on every computer, and I can't do that on mobile devices. So I run a Pi-hole. This handles all of my DNS requests for the client computers in the house, and it forwards local requests to the main DHCP server in the house and the rest out to the internet over DOH. It also does a fantastic job of blocking internet advertisements. I've already deployed the DOH servers in DigitalOcean and Lightsail. Lightsail and OpenCloud cost about $5 a month for a system with 1 core, 1 GB of RAM, and some disk. That's perfect for K3s. If you don't know about K3s, it's a super lightweight Kubernetes distribution that is perfect for resource-constrained environments. All of Kubernetes runs in 512 megabytes of RAM, so you can run it on cheap ARM hardware or in a VPS. It's also super fast. To deploy K3s, I'll use the Ketchup utility created by Alex Ellis. I'll put a link to it in the description. This works a lot like RKE, running from my local workstation to install K3s onto another system via SSH. Once installed, we just need to open up 6443 for access to the Kubernetes API, and I like to open the node port range as well. I'll manage this instance with my main Rancher server out in DigitalOcean. We can import K3s clusters into Rancher, and while that's happening, I'll just rename the clusters so that they make a little bit more sense. Once the cluster's up and in Rancher, I'll deploy Cert Manager from Jetstack. Y'all know I love me some Cert Manager. But this time, instead of deploying it via Helm, I'll just deploy it with the direct manifests, first creating a namespace and then applying the manifest from the URL. Then I deploy a cluster issuer for Let's Encrypt. This is all in the Cert Manager docs, and I do it in almost every video that I make, so I don't think you need me to spend much time on it. The only thing that's different for this installation is that K3s runs traffic as its ingress controller. The Cert Manager docs use an ingress class of nginx in their sample configs, and if you don't change it, well, you're not going to be able to deploy certs. To deploy the actual workload, I'm going to run my DOH tools container, but I'll modify the command to run the server. Remember that the application wasn't created for containers, so there's no way to configure it via environment variables. I might update the code to support that, since it'll make configuration a whole lot easier. We need to tell it where to forward requests, and for that we can grab the kubedns service address. We also need to specify --trusted so that it will accept requests from anywhere. Because we're running this behind a reverse proxy, we can just use the HTTP proxy option instead of the actual SSL wrapped server option. Now, do we want to accept requests from anywhere? Maybe, maybe not. Obviously, any of you can connect to any of these DOH servers and proxies unless I tear them down, and I usually tear them down. The DOH tools don't expect to be running inside of Kubernetes, and I'm guessing that even though --trusted exists, we can probably do some stuff within Kubernetes itself to secure these endpoints. I'll have to explore that in a future video. The next step is to add an ingress for the DOH server service, and then modify the YAML to request a cert from Let's Encrypt. Once again, this is all standard stuff, and we should just zip through it. Okay, so I've got a cert in front of the server, and I can test this with the DOH client from the DOH tools container. If you didn't see last week's video for how I get that command to run on my Mac, I'll put a link to it at the end of the video, and there's probably a card up here that has it as well. Last week's video was about setting up a DOH proxy to load balance across multiple third-party DOH servers. I've deployed that here in the system closest to my house, but I want to change its config to point to the DOH servers that I've just deployed. Those are under my control. I'll edit the config map, and I'll change the settings for the first 2 servers. Notice that because our DOH server is running behind an ingress controller, we need to tell nginx to add a host header to the request. If you don't do this, well, the request's 404s. The third server runs on the same node as the proxy, so while I could bounce the request out to the public IP, doing so isn't efficient. In the case of AWS, it also costs extra to use the public IP from within the private network. In other providers, it might not work at all if the NAT implementation doesn't support hairpin requests. So it's better to send it to the DOH server's cluster IP service, which keeps everything within the cluster. A quick update to remove the 4th server from the config, and we can redeploy the pod to pick up the new config. Now, when we run the client against our proxy, we can see it cycle through our Lightsail node, then the DigitalOcean cluster, and then do a private IP for the local server. The last step for me is to update the Pi-hole to use the new proxy. The Pi-hole documentation has instructions on how to enable DOH via the Cloudflare D daemon, but all that does is behave like the stub and convert DNS requests to DOH requests. So all we have to do is point it at our proxy and restart the service, and then a quick dig at the local port shows that it's working. With the Pi-hole updated, I can see other FQDNs in the server log, which tells me that the whole thing is working end to end. The last part of this gave me a bit of grief as I decided the best way to handle deploying the proxy. I considered running the stub server in my local Kubernetes cluster, but that would have put a dependency on Kubernetes for DNS to work. If I were to reboot everything, the Pi-hole would come up, but it would need Kubernetes to come up before it could serve DNS requests. Kubernetes itself forwards requests to the Pi-hole, and that loop could have created a failure. I also considered running K3S alongside the Pi-hole software and running the local stub server instead of Cloudflare D. It didn't work because the Pi-hole and K3S both want to listen on port 80 and 443, and I didn't really feel like trying to make that work. I briefly considered deploying another Raspberry Pi node as a standalone system to do the DNS forwarding, but I didn't want to create a solution that requires that you run more hardware to get any sort of benefit. It does make me think that I need a second Kubernetes cluster for some infrastructure stuff, and K3S would make a Raspberry Pi cluster totally feasible. You might have seen that Cloudflare D supports multiple upstreams, so the best solution is probably just to point it directly at each of my 3 DOH servers. As it's configured now, if the proxy goes down, all public DNS resolution for my house would also go down. In the world of possibilities, it's more likely that the proxy would be down than it is that all 3 of my Kubernetes clusters and 3 different providers would be down at the same time. In the end, I decided to just make the video using the proxy because it's in the same city where my traffic egresses anyway, and it brings a nice bit of closure to the whole configuration. Let me know in the comments, where would you put the proxy? Would you put it in your local network? Would you put it outside? If you don't have a Pi-hole, would you run the stub in Kubernetes or on a standalone system? If you liked the video, please give it a thumbs up and subscribe to the channel. I release a new video every week, and if there's something you'd like to see, you can let me know in the comments below or on Twitter, and I'd be happy to make it for you. Thanks so much for watching. I'll see you next time.